So this is a lightning talk, but there's a poster session right afterwards, so hopefully I can at least give you enough information to know if you're interested in coming and looking at the poster. Of these people, Bernie Pope is also here in the audience. So I think probably everyone here is already familiar with the concept of pipelines, workflows who are trying to automate an analysis. And in genomics using next-gen sequencing particularly, we tend to have lots of files, big files. You will inevitably get new files partway through your analysis. You will inevitably change your analysis partway through the project. You really want to be able to rerun stuff and run the new data and not the old data and not be commenting script lines out all the time. So you want to automate in a way that copes with all these things. You're often also running in some kind of parallel environment, like an HPC cluster. And in my work at least, you pretty much always need to automate your analysis in a way that uses the file metadata. So in this case, it's the same problem that Ennis was talking about. Conceptually, it's that you need to merge the files that come from the same sample. So whatever automation system you use needs to take care of that. And in this particular case, you have 5 processes which you could parallelize, if you really want to parallelize, to generate band files. Then you have to look at the metadata, and then you're going to have 2 processes which are also independent of each other to merge those band files. So because of these kinds of requirements, people tend to write pipeline frameworks. And I think we've already seen at least 4 Python-based workflow frameworks in this conference alone. So the one we're using is Rufus, which is not ours. So we didn't reinvent the wheel, but we picked the wheel and we rolled with it. And we picked Rufus because it's pretty flexible. It handles all our corner cases, which is really important. You don't want to be stuck with something and find there's just one thing you just can't do. It seems to have a good developer community and user community, and it's got some nice features. And Rufus works like many of the frameworks you see. It's essentially like Make, so it calculates dependencies, runs the things that need to be run. It uses Python decorators, so you get flexibility of Python, and it addresses this metadata handling problem using regular expressions, which I won't try to explain because there isn't time. It's also got some nice features, so it will parallelize anything that can be parallelized. It'll do logging, it'll let you visualize your task dependencies, among other things. So Bernie wrote some code to help us use Rufus on our clusters, and that got used extensively, and eventually it evolved into this command line tool, Rubra, which uses the Rufus library. So it exposes the Rufus features through command line syntax, which is quite nice, so you don't have to write boilerplate code or go in and tweak your scripts every time you just want to invoke the pipeline differently. And it also adds some features that aren't in Rufus itself, which we needed. The most important ones are probably checkpointing, so checking for successful task completion, and job submission to an HPC system like Talk PBS. So at VLSCI, we use Rubra and Rufus to write all of our analyses, and we've started trying to release them kind of as part of the GVL project as hopefully reusable pipelines. So this is the first one. It's for basic variant calling and annotation, so it's based around the GapK recommended best practice for alignment cleaning and variant calling. And it uses the ensemble variant effect predictor for basic annotation of variants. It's got a whole genome version and an exome version as a branch in GitHub, and it's really just been released. So if you want to look at it and have bug reports or feedback and suggestions, that would be great. Contributions would be even greater to this or to Rubra itself. We've got a poster which has more details and kind of code examples of this and kind of how Rufus works if you haven't seen that. So if you think you would like to work on this stuff or just use it, please come and have a look and talk to us.